Swayam Prabha. Digital India. Educated India.
Lesson 2.3 Traffic Studies Part 1. After completing this lesson, the student will be able to carry out traffic volume studies using different field techniques. So, they will expose to different field techniques and they will be able to carry out traffic volume studies. Student will be able to present traffic volume data in suitable ways. There are different ways traffic data are presented for meaningful interpretation and analysis. So, they will be able to present traffic data and also carry out spot speed studies by field measurement of travel time over a short distance. There are different ways for carrying out spot speed studies. So, in this part, after covering this part, they will be able to carry out spot speed studies by field measurement of travel time over a short distance. For various reasons, it is necessary to carry out traffic studies. There are several types of traffic studies what are carried out, including traffic volume study, speed study, within the speed study also spot speed study, speed and delay study, traffic capacity study and level of service, origin destination study, parking study, accident study, and there are so many other kinds of studies, specialized traffic studies. Now, they are all different types of studies which are required to carry out be carried out for specific purposes. Now, in this lesson we are not going to discuss about all the traffic studies, but most commonly used traffic studies like traffic volume studies, spot speed studies, speed and delay studies, those are the three major and commonly used traffic studies that we will cover. Coming to traffic volume studies, counting is the most fundamental measurement in traffic engineering, counting of vehicles, counting of persons. So, for various reasons we are required to go for counting. So, it may be person, it may be vehicle, but counting is the elementary requirement, how many people, how many cars or how many traffic vehicular traffic in general. So, counting techniques are used to produce estimates of traffic volume, rate of flow, demand and capacity. Now, they are related terms. So, let us try to understand them. First is the volume. What is volume? Volume is basically number of vehicles or persons, as I indicate, it may be vehicle, it may be person, passing a point during a specified time period, which is usually 1 hour, but need not be. That means, during a period of time, it may be 15 minutes, it may be half an hour, it may be even 60 minutes or 1 hour. How many vehicles or persons are passing a point during that time period, that is known as volume. Rate of flow. Rate of flow, it is vehicles or persons passing a point during a specified time period less than 1 hour expressed as an equivalent hourly rate. That is what is the difference. Here maybe if I carry out for study for 30-minute duration, I may say what is the volume in 30-minute, I can express it, but when the same 30-minute volume, when I express it as an equivalent hourly volume, that means if 30-minute, if there are x vehicles, then in 1 hour it is 2x. So, I say rate of flow is 2x vehicles per hour. So, that is the difference. One is the actual number during the specified time and another is the number expressed as an equivalent hourly rate. Demand, yes, through traffic volume studies we also measure the demand, not always, but in many cases we measure the demand actually. It is number of vehicles or persons desire to travel past a point. Carefully observe this part, desire to travel. Whatever we are actually measuring in the field, we have to be careful whether we are really capturing all those who desire or we are capturing only a part of that. So, number of vehicles or persons desire to travel past a point during a specified time period, again usually it is 1 hour, and capacity is maximum rate. Carefully observe this part, it is rate at what can be observed again and again. It is not the maximum volume that once in a lifetime is achieved, not that. What can be achieved again and again. Maximum rate at which vehicles can traverse a point or short segment during a specified time period. It is also again expressed as rate, that means hourly flow rate. We shall elaborate more on this capacity definition. We are just introducing the capacity terminology here, it is the maximum rate, but there are other aspects which are also essential to define capacity in a complete form. So, we will come back to that part. Now, traffic volume studies is our focus here for this lesson. Volume studies are carried out primarily at mid-block locations and at intersections. These are the two places where normally we carry out traffic volume studies. If you take up a road, these are mid-block sections and there are intersections. So, within that intersection area, within the intersection influence area, we normally call that location as intersection block, and away from intersections, that stretch which is or which are free from the influence of intersections are called mid-block locations. So, we carry out traffic volume studies for mid-block locations as well as for intersections. Now, next point comes, what should be the period of volume studies? For how much period we shall carry out the traffic volume studies? This again, it all depends on the purpose and use of the data. What is the reason or why we are carrying out traffic volume studies? So, it may be like peak hour or peak period, morning peak, evening peak, or maybe 12-hour volume count, it may be 16-hour volume count, it may be 24-hour volume count, it may be 7-day volume count. So, it is possible to have traffic volume studies maybe covering only peak hours to maybe 7 days, even 365 days in a year at permanent count stations. So, basically it all depends on the purpose. So, we have to understand why we are carrying out traffic volume study, what is the possible use of that data, and accordingly we have to decide what should be the duration for carrying out studies. Coming to the field techniques for volume studies, wide variety of techniques and equipment are available, starting from the very crude or very simple way of doing that to using very sophisticated equipment or technology, advanced technologies. Wide variety of techniques are available, starting from paper pencil mechanical hand counters, pneumatic road tubes, up to even satellite based system, etc. So, I have mentioned it in the order of say simplest to most advanced or technology supported ways and means for doing volume studies. There are wide variety of techniques that are used, but most studies use simple techniques and basic technology. Question is why? The answer is time and cost. Say, as I have told, you can even use maybe satellite based system, but we have to look at the need for the project, need for the data what we want, what level of accuracy what is really necessary for the project. If we are talking about very sophisticated technologies, that may be too expensive and it may not be possible to set up that equipment or system within a very short period of time. On the other hand, if you are using say manual based count techniques, accuracy may be little bit limited in some cases. Of course, you can improve the performance, there are so many ways and means to do that, but in some cases or in almost in all the cases it is very simple, you can quickly set up and it is not expensive. So, mainly considering the time requirement and considering the cost requirement, most studies are carried out using simple techniques and basic technology. These are the two things. Now, common counting periods, as I told, it may vary widely depending on the need, but still trying to be to give you little bit idea about say for mid block counts. Normally, that is the duration of studies, and this we are talking about the count period. Now, these two are different. Duration of studies means for how much period should I carry out traffic volume studies, for one day or peak hour or during peak 12 hours or 16 hours, that is the counting period. Now, then is what is actually period of study is known, then what should be the duration of counting? Should I make 15-minute count? Should I record 15-minute traffic volume data, 5-minute traffic volume data, every minute traffic volume data? That is the question we are trying to answer. Now, for mid block studies, normally 5 minutes or 15 minutes counts are used. That means, we record the total data, that is the most disaggregated level we collect the data. So, we will have 15-minute data, then we may add 15-minute data and then try to get hourly flow and then want to see the variations and all sorts of things. But common count periods for mid block volume studies is 5-minute or 15-minute. Now, remember that we normally do not use very small period of counting, because you may get very instant fluctuations in traffic volume, which are not steady traffic volume. So, if we try to calculate the rate of flow by multiplying proper duration of counting or time, then we may get very high value or unusually high value, which are not practical, which are not steady flow. So, normal duration of counting is 5-minute, 15-minute for mid blocks, and for signalized intersections it is carefully observed equal multiple of cycle length, because we cannot say whether it is 5-minute or 15-minute or 3-minute, but it should be equal multiple of cycle length, because signalized cycle means cycle length is the unit. So, it should be multiple of the cycle length. First, coming to manual count techniques. Manual count techniques, as I mentioned, they are relatively inexpensive, can generally be set up in a short period of time. You can quickly set up count techniques. These are the major two advantages for which we can or we go for manual counts. there are other advantages also, like several parameters can be observed, which for automatic or machine based recording system, automatic recording system, it is difficult or impossible to observe practically, like vehicle occupancy. Then turning movements, how many are turning left, how many are turning right, how many are going straight in an intersection. So, this kind of data, occupancy data, turning traffic data, vehicle classification data, how many are cars, say we are using sophisticated equipment, maybe we will be able to classify car and bus, but within car, suppose if we want that private car and taxis are to be recorded separately, because taxis generally have fixed color. So, you can understand very well looking at the car vehicle itself, you can understand this is a taxi and that is the other vehicle may be a private car. But automatic count, it is very difficult to classify them, which one is taxi and which one is car, private car. So, some cases manual count techniques are extremely useful, because a large number of parameters can be observed, like vehicle occupancy, turning movement, vehicle classification, etc. But manual count techniques involve unique challenges, which also to be understood very clearly. Challenges in terms of coordination of personnel. So many people are working, maybe if you are carrying out traffic volume study at a mid block location or at an intersection, maybe some 10, 15, 20, 30 people might be working. Coordinating the work, coordination is a major challenge. So, that part is to be ensured. Then accurate observations and recording of data, this is again a challenging task, because manual component is involved. Sometimes all the people may not be equally serious when they are in the field. So, you have to ensure that they are really doing the work, they are really looking the vehicle and recording it, either using pencil and putting tally marks or using some kind of counters. So, this is a manual process. So, you have to make sure that they are serious and they are really doing the work, recording the data is correct, even accuracy of observation and recording, those are very important. Then also organization of the data. These are some of the unique challenges involved in manual count technique. We carry out paper and pencil based manual count, okay, where we use well designed field sheets and tally mark. So, like there will be a fixed format where required vehicle classification will be given, time period will be given, and enumerators, normally we call them enumerators, those who collect data in the field, particularly traffic volume studies, for traffic volume studies. So, they will actually use paper and pencil based noting down or recording of data. So, they will simply put tally marks and then try to do that. Normally, we put tally marks like that 1, 2, 3, 4 and then 5. So, and then again 1, 2, 3. So, that means now 8 vehicles have been counted. So, well designed field sheet and tally marks we used. This is paper pencil based manual count. Equipment aided manual count is also common. Here most of the times the commonly used thing is mechanical hand counters. So, mechanical hand counters are used, they are simplest equipment, right. A single mechanical hand counter normally can record 4 different items. Normally a single mechanical hand counter can record 4 different items, maybe 4 different vehicle types from one approach. So, maybe one person using a mechanical hand counter to observe traffic volume from an intersection approach, maybe 4 different vehicle types he can record. Maybe one is car, another is two wheeler, another may be bus, another may be commercial vehicles, just an example. So, 4 different items may be recorded by one hand counter. So, suppose we need to record 4 different vehicle types for all 4 approaches simultaneously, then maybe we require 4 mechanical counters to observe 4 approaches of a typical intersection. In mechanical hand counters, generally data is recorded and periodically transferred to field sheet. automatically we just press the button. Once you observe a vehicle, you press the button, again you observe a vehicle, you press the button. So, then periodically this data to be transferred to the field sheet. So, when you are transferring it, you are essentially giving a break. So, in this process it is required to give short breaks in counting. Why these short breaks? Let us again try to understand it clearly. Because we need to transfer the data from mechanical hand counter to field sheet periodically. So, when we are transferring it, that point it is not possible to really count and record the vehicle volume. So, during the process of transferring the data, there is a break that is necessary. So, it requires short breaks in counting. In two different ways, the short breaks can be introduced. One is a portion of each counting period is set aside for a short break. Again, let us try to understand that. Suppose if it is a 15-minute counting. Okay. So, every 15 minutes we are trying to record the traffic data. That means 15 minutes, 6 to 6:15, how many traffic volume, 6:15 to 6:30, how many traffic volumes, like that. So, it is actually for 15 minutes, but we may record traffic volume data for 13 minutes in every 15 minutes, and 2-minute time we can use for transferring the data. So, 13 minutes out of 15 minutes, or maybe 4 minutes out of 5 minutes, if it is 60-second signal cycle, because as I told it has to be multiple of the cycle length signal cycle, or maybe 12 out of 15 minutes if it is a 90-second signal cycle. Now, why I have mentioned it here 12 out of 15, 4 out of 5, because look at this thing, these are all multiple of the signal cycle, that is why I have mentioned it in this format. The other alternative is, do not take 2 minutes or 1 minute from the counting period, but do the counting alternatively. That means, every other count period is used as a short break. So, suppose if it is 15-minute duration counting, we will do counting for 15 minutes, next 15 minutes we do not count, again next 15 minutes we count, next 15 minutes we do not count, like that we proceed. Obvious question is, yes, now we have understood how we introduce short breaks, but then the question comes, how we will adjust short breaks? Yes, there are simple ways one can adjust these breaks. If we are following the first method, like 13 minutes out of 15 minutes we are doing the counting and we want to know the traffic volume for 15 minutes, what we do? We assume the rate of flow during short break same as for the observed portion of the count period. That means, suppose if I have observed x1 number of vehicle, okay, in 13 minutes, then this may be the traffic volume x1 by 13 into 15. I will assume that that will be the traffic volume during 15-minute period. That means, I am assuming that rate of flow during short breaks of 2 minutes is same as for the observed portion, whatever we have observed in 30 minutes during that counting period, whatever rate of flow we have observed, it is the same one. If we are following the second method, like every other count period we are using, then a straight line interpolation may be done to estimate the counts during the break points. Like if I plot it, say time wise, if we do, here I have worst here, second I have not observed, third I have observed, fifth I have observed. So, I may do interpolate it, whatever is the in between traffic. So, here it is this volume, here it is this volume. So, I can simply straight line interpolation may be done to estimate the counts during the break periods. From this discussion, it is obvious that introducing breaks means, yes, there are alternative ways we can introduce breaks. There are ways also we can adjust this traffic volume to take into consideration the effect of brakes. But it is obvious from this discussion that it is advantageous to use equipment which are capable of recording and storing data electronically in a machine readable form that can be directly downloaded to a computer using a data interface, more advanced technology. So, logically I need not elaborate much on this point, because it is understood that such kind of equipment will definitely be advantageous. There are equipments capable of doing this kind of thing. Now, as I mentioned earlier, that manual counts are simple, economical, can be set up quickly, but there are certain unique challenges, particularly personal consideration for manual counts. Let us try to understand those points. It is necessary to design field sheets with clarity. Every field sheet should be very clear, where the volume count is happening, for which direction, what are the vehicle types, what are the duration of counting, what is the day, what is the time, what is the climatic condition, and where to record the data, whether to use tally marks or some other way the entry to be done. So, field sheets to be designed carefully with clarity, that is the first point. Second point is, as a first point, continuation of first point, we can say, I have tried to indicate some of the common elements which are included in the field sheet, like location, observer's name, specific movement details, whether the left turning movement is taking or right turning or the straight movement, what are the vehicle types that are getting recorded in a field sheet, what is the weather condition, date, day, time, what is the counting period that is used, and normally suppose if you are taking 15-minute count and the period of the volume study is 8 hours, say for example, then so many sheets will be required. So, it is normally helpful to put like this page x of y. So, page 1 of 10, 2 of 10, 3 of 10, like that. So, we know that those 10 pages are traffic volume data for a particular location, for particular vehicle types, for particular directions. Then the second important part is, all personnel must be properly trained, because it is enumerator or field people who are going to record the data. So, they must be trained properly. They should understand each and every column or each and every information which are there in the field sheet and which are to be recorded in the field. So, a total clarity is necessary in terms of understanding the field data, understanding the survey, what to be recorded, where to be stored, how it is to be written, what are the other places that the enumerator should fill up. All this equipment, all these things must be known to this personals, key personals or field people. So, purpose, why they are carrying out the thing, what field sheet they are using, what equipment to be used, where the survey to be carried out, which approach of an intersection may be, for example, to be taken, what are the vehicle types a person will record, all these should be known, and that is possible only when enumerators are trained well in advance. So, before you go to the field, you have to train enumerator, sit with them, explain them, maybe carry out a pilot survey if necessary, to make sure that they have understood the requirements. Avoid too many observers at one location may distract drivers and cause traffic disruption. We want to record the natural condition. In a natural condition, what is happening, that we want to record. So, if too many people are making a crowd in one place, the drivers may think, the vehicles may think, what is happening here. So, their movement, their natural movement may get disturbed, we do not want that. So, that is to be avoided. Time must be carefully coordinated at all locations and among all counting personnel. Maybe at a time 3 intersections are covered for traffic volume studies. Now, at all the 3 intersections for all the people, the watch should be, or the clock should be coordinated. They should start at the same time. If it is 9 o'clock at all intersections people should write 9 o'clock, otherwise one places people will write 9 o'clock, another 9:05, another 9:10. So, that will give problem, that will give difficulties in terms of interpretation and analysis in the of the analysis part. So, time must be carefully coordinated at all locations and among all counting personnels. Number of counting personnels to be decided judiciously. It is very difficult to give a rule how many persons will be required. One should basically go to the field, see at what level he wants to collect the data, or it is necessary to collect the data, how many vehicle types, how many approaches, how many traffic lanes are there, what is the traffic volume, what are the different shares, average shares of different vehicle types in the total traffic volume, and then one can decide how many personnels or how many persons will be really required to do the survey or to the studies in a proper manner with desired level of accuracy. Suppose there are two vehicle types you give to one person, and both vehicle types there are a lot of vehicles. So, you may not be able to count that. So, one should judge. So, give maybe one traffic vehicle type which is generally predominant in the traffic stream, and maybe with that one more vehicle types which occasionally is coming in the traffic stream, that may be possible. So, you have to decide the number of counting personnels judiciously. Relief personnel must be provided, because it is almost we need the enumerators to count the traffic continuously. So, it is say 8 hours a person cannot work continuously, he will require maybe a cup of tea or need to go outside for drinking water, for taking rest for 5-10 minutes. So, you must provide adequate relief personnel. So, in rotation everybody gets break, otherwise if you do not provide, then the quality of the work, they will not count, they will probably go away, and that period will be there will be no counting during that period. Finally, the most important thing I believe is work carried out by counting personnel must be supervised. There should be supervisors, for adequate number of supervisors who should be present there to supervise whether really the coordination is there in the overall work, everybody is working properly, everybody is recording the number properly, correctly in a systematic manner. So, whole system of data collection is working in a smooth manner, that is to be ensured by proper supervision. So, that supervision is very necessary. Portable count techniques, this is another kind of count techniques. It include all count equipment which are using pneumatic road tubes or other maybe other temporary detection equipment. Okay. We are calling it as portable count techniques, because this pneumatic road tubes or temporary detection equipment can be transported from one location to another location. You have carried out traffic volume studies at location A, you can take the whole setup and go to location B. So, we are calling them portable count technique, that is why this term is coming, portable. Coming to pneumatic road tubes, it is most frequently used portable equipment. Tubes are fastened across the pavement, you just place them across the pavement. As vehicle pass over the tube, pneumatic pulse is created in the tube and sensed by counters which are connected to the tube. So, that way it can understand, yes, one axle has crossed this tube, because the pulse goes and counters can sense that. Remember that counters record number of axles that cross the tube, not the number, because the pulse is generated every time an axle cross the tube, right. So, that pulse is generated. So, it can how many pulse is getting generated, pneumatic pulse is getting generated, that will be an indication how many axles have crossed, it will not give the vehicle number directly. So, it is necessary to carry out studies at least for some sample period to estimate the average number of axles per vehicle. Normally, I am sure many of you might be thinking it is 2 axle, but it is not really so. If you do the survey traffic volume studies on highways, there are so many commercial vehicles which are having axles maybe more than 2. So, if we observe the number of axles on a sample basis, then we can calculate the average number of axles for that given locations which are applicable for that given location, and accordingly from the recorded pulse, pneumatic pulse or number of axles, we can divide it by the average number of axles per vehicle to get an estimate of number of vehicles. Roadside counters can be hooked up to other types of detectors, say for example, loop detectors which can count vehicle classes directly. Road type tubes may be applied in a varieties of ways. There are so many ways the road tubes can be applied. Maybe a single road tube stretched across both directions of travel. So, maybe this is one direction, this is another direction, you put one road tube, okay, and that is recording both directions of movement. Separate road tube for each direction of travel, if it is a divided road, maybe with a divider or median in between. So, one road tube here, another road tube there. So, separate road tube for each directions of travel, or a sequence of road tubes for lane counts. Even in one direction there could be some 3 or 4 lanes. So, it may be necessary to record the traffic volume data lane wise. So, if one pneumatic tube is placed across all the lanes, then we know the total volume, we do not know the lane wise distribution. So, if necessary, a sequence of tubes may be used for lane counts, but it is not a very common practice, it is not done commonly. Most of the cases we use separate road tubes for each direction of travel. Remember that if not fastened firmly to the pavement, if we are not fastening the tube properly on the pavement, then road tubes may get damaged, because as the vehicle crosses the tube, number of vehicles will cross the tube and the tube will eventually break. So, you have to make sure that tube is fastened firmly to the pavement, and when used across multiple lanes, there may be some simultaneous actuations and which will occur, and therefore, you may get slight undercounts. Now, why it is happening? Every time a vehicle crosses the tube, the pulse will go. So, if there are multiple lanes and at a time maybe 2 vehicles are crossing the tube, it may not happen all the time, but it is possible that occasionally 2 vehicles may cross the tube at the same time. So, a single pulse will go and it would be recorded like a single axle has crossed the tube. So, it may result in slight undercounts. There are permanent counts, which stations where the counting is carried out 24 hours a day and 365 days a year. A variety of permanent detectors and data communication interfaces are used to deliver the results to a remote computer system for storage, manipulation and analysis. So, 24 hours 365 days, this permanent setup is available and it is counting traffic volume data. Permanent count station on highways specifically for counting traffic volumes and understanding traffic growth pattern, etc. Now, with this highway development part, it is very much necessary for us to understand the traffic growth, how the traffic volume is growing, what is the seasonal variation of traffic, not that monsoon, winter, summer, okay, traffic volume is not same. So, how the traffic volume changes from rainy season to winter to summer. So, permanent count station traffic data is a very valuable source for estimating seasonal variation, for understanding traffic growth factors and all sorts of other traffic data requirement. Modern actuated signals, toll collection systems and traffic management system contain detectors to get traffic data mostly for online real time monitoring. Some of these may be designed as permanent count slides. So, idea is that they are doing the traffic counting, but this is for online monitoring, not really for the purpose. It is not really working like a permanent count station. It is recording the data, but the purpose is different. Purpose is online monitoring. So, some of these places may be converted with additional little bit accessories and equipment, to work as permanent count station data. Finally, remember the technology of traffic data collection is advancing rapidly. The major concern is the cost for widespread application of advanced technologies. I indicated in the beginning itself, you have the technologies available, there is no problem, but is it economical to use those technologies for common purpose? The probable answer is no. So, the cost is a concern for widespread application of these advanced technologies, and even use of video imaging and virtual detection, this is also advancing rapidly. Maybe after some time, or already in some places it is available also, at least at research level it is successful, that the video imaging or virtual detection system to do the traffic volume count and collect so many other related data. How to present the traffic data? There are so many ways the traffic data may be presented. Average daily traffic, traffic composition, hourly variation chart, turning movement diagram, this is applicable for intersections. So, there are so many ways this traffic volume data may be presented. Let me quickly show you some of those things. This is the average daily traffic data. I know it is difficult to read anything from that, you need not read the number really, but what are the information that we are trying to put in a concise form, that one should observe carefully. This I have given the project. So, you give the project name, this is the count station number, date and time, direction of travel, what is the terrain condition, what is the weather condition, what is the district, it belongs to which state or which part, this is the road name, location, everything. Now, here what we are trying to show is a typical example of representing 7-day traffic volume data. So, this is Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So, this each day, then there are two broad classes, fast moving vehicle, slow moving vehicle. Then under fast moving vehicle, there are other different vehicle classes like two wheeler, three wheeler and all sorts of thing. Further two columns are one for up direction traffic, another for down direction traffic everywhere. You take another thing, this is for up direction traffic, this is for down direction traffic. And here we are presenting the average, what we have observed 7-day average. First row is number, so this is the representing the number. The second is the equivalent volume in passenger car unit or PCU. So, you know the concept of PCU also. Then with that we are estimating ADT, because this is 7-day traffic volume count. So, what is the ADT? Okay, considering up, down direction and vehicle wise separately and then doing the total, and this is the one which we are showing the directional split, up and down, what is the split. So, you can see in a very concise form, so many information, related information you can present. So, I have shown the 7-day variation, I have shown the vehicle wise what is the number, and then in vehicle number, in PCU, up direction, down direction, slow moving, fast moving, doing the ADT calculation, everything through a concise form. Now, there are, you can be innovative to design your own average daily traffic representation chart, but this is just an example. This is an example of how you represent traffic composition over a given period of time. What are the share of different vehicle types in the total traffic stream, that can be presented easily with a pie chart. Then this is showing the hourly variation chart. It starts from 7 o'clock in the morning, goes 7 o'clock in the morning next day. So, 24 hours how the traffic volume is changing. One I am showing separately for fast moving vehicle, another for slow moving vehicle, this one pink one, and this is showing the blue line showing the total vehicles. It is basically that you can show the fast moving vehicle, you can show the slow moving vehicle separately, you can show the total vehicle, you can show in number, you can show in PCU, but this is a form that you present this hourly variation, one can easily understand. Then this is a way of representing turning traffic movement count, how we are presenting the thing. Okay, there are other ways of presenting that. Suppose what is the total traffic is coming here, then how much is taking left turn, how much is going straight, how much is taking right turn. So, if you come here take another approach, what is the total volume coming, out of that how many is coming from this direction, how many is coming from this direction, how many is coming from this direction, like that. So, in one figure itself you can show all the traffic volume, all the turning traffic, how many are coming, how many are leaving each approach, and how they are getting distributed, how many are entering into each approach, where from they are entering, and all these things. This may be for peak hour, we represent it what is the happening in the peak hour, and accordingly this goes as an input for traffic signal system design or traffic signal design. That is about the traffic volume studies. Now, coming to spot speed studies. You know what is the spot speed? It is a measurement of speed of vehicles passing a point on a highway. It is a point measurement over a period of time. Now, traffic engineers, remember that they are generally interested in spot speed studies under condition of free flow, because that is where we can use the spot speed data. If the road is under congestion, if the speed has already come down drastically, then there is no point in carrying out spot speed study. So, engineers, traffic engineers are normally interested for spot speed studies when the traffic volume is not heavy, or rather the traffic is flowing nearly at a free flow condition. Remember that spot speed studies are generally not conducted when volumes are in excess of, not conducted when the volumes are in excess of 750 to 1000 vehicles for freeways and 500 vehicle per hour per lane on other uninterrupted flow facilities. So, if the traffic volume is more than this suggested range, normally we do not carry out spot speed study, because this is an indication that traffic is no more at a free flow or near the free flow state, already congestion has started occurring. If you measure the spot speed at different, for a given situation, the road is fixed, the environment is speed. If you measure speed of different vehicle types, you will find the speeds are not same, not that you observe 10 or 20 or 100 vehicles, not that they will give the same speed. So, therefore, that is an indication that measurement of speed of individual, if you do, they cannot be same, which is an indication, or the result is a distribution of speed. So, that is why we say speed follow certain distribution. When it is a distribution, so speed is distributed following certain distribution. So, when it is a distribution, some key statistics are required to describe spot speed distributions. What are the key statistics that are normally used? Average or time mean speed, average observations over time, standard deviation, 85th percentile speed, median value, etc. They are the key statistics which are used to describe spot speed distribution. Now, what are the uses of spot speed data? Spot speed data is used for various reasons. Studying the effectiveness of speed limits or enforcement practice, you might have given a speed limit, whether people are really following it. Do the spot speed study and see what is the speed of vehicles. For suggesting appropriate speed limits, it may be other way. You do the spot speed study and then you see whether it is necessary to study or to suggest a speed limit, whether really the vehicles are speeding up. Studying the speed trends and assessing the effectiveness of policy on speed limit and enforcement, different ways these things are told. Studying speed performance with respect to specific design applications like steepness, what is the effect of stiffness on speed, what is the effect of length of grade on speed, what is the effect of alignment on speed. So, we want to study this performance with respect to specific design applications. investigating high accident location where speed is suspected to be a contributing factor. Maybe overspeeding you are thinking is a cause for the accident at certain locations. So, we want to investigate whether really overspeeding is taking place. So, we may carry out spot speed studies. So, there are various reasons why we need to carry out spot speed studies. Coming to the measurement techniques, there are two alternative techniques which are generally used. One is measurement of travel time as vehicle traverse a short measured distance. Basically, you have a trap length or node measured distance, short trap length, known distance. So, how much time the vehicle takes to cross this distance, take the time and accordingly calculate the speed. That because the section is or the stretch is very short, we are considering it as a spot speed or speed at this particular point. The second approach is use of handheld or fixed mounted radar meter. We call it radar gun, radar meters. Okay. So, this is another equipment which is also used for spot speed measurement. We will discuss about the first technique today and discuss about this radar gun and related aspect in the next lesson. Several advanced techniques are available, but remember that again their use are limited because of the cost considerations. Detectors capable of measuring speed and other parameters there are available which are normally used for multi-parametric studies. Video technologies are available which can be used for volume count, speed measurement and so many other things. But again cost is a major consideration for widespread application of these advanced technologies for common day or common type of studies. Coming to the measurement of travel time as vehicles traverse a short measured distance, it is simplest, cheapest and easiest method. Basically, we use manual use of stopwatches to time vehicles as they traverse and easily recognized trap. There is easily recognized traps. So, we observe using stopwatch when the vehicle enters here and when the same vehicle leaves this place, how much time it has taken to travel this distance t. So, we press the stopwatch here to start it, again press the stopwatch as it exceeds the section. So, we know what is the time required. Then trap can be marked with white tapes. On the road you just put maybe 2 white tapes. So, you can easily see these are the tapes. So, this is my trap length. Sometimes some natural or artificial features also you can put some cones or you can refer to an electric post or maybe a tree which is there like that. Observers usually stand at the location of one of the trap boundaries, usually the entry boundaries. So, suppose if it is there, observer will stand here. So, this ensures viewing vehicle crossing one boundary without any distortion. So, obviously, the vehicle is crossing, he is standing here perpendicularly, he can see that thing without distortion. But this automatically ensures that the viewing vehicles crossing the other boundary with distortion. This he cannot see both the vehicles without distortion. So, if he is seeing one vehicle without distortion, the other vehicle he is seeing obviously with distortion. So, this systematic measurement error is created and it is called parallax. So, parallax is the systematic error that we are referring to and it is a systematic error and can be corrected. Let us see how we can correct it. Here I have tried to explain the thing. The observer is standing here as the vehicle is crossing, he is viewing this vehicle here. Okay. So, it is absolutely no problem. When this vehicle crosses this line, this is the exit line. So, this is the observer's line of sight. So, the vehicle is actually here, but the observer is getting an obstruction to this line. So, he is thinking that probably vehicle has crossed. So, vehicle has actually travelled this distance which is d effective rather than actual distance d. So, a correction is necessary. This correction can be applied easily if we know this angle phi. If you know this angle phi and if this distance is d1, then you can calculate this d effective is nothing but d1 tan phi. So, if you know the distance, apply that. So, calculate the speed taking this d effective divided by the time. there could be error due to early or late depressing of stopwatch, but this tends to be random. So, can be minimized, can get cancels out. Of course, this error can be minimized using longer trap length, because more it is the actual travel time, the percentage error would be less, but obviously we cannot make it too longer, then the meaning of spot speed will be lost. Question set: discuss the personal considerations for manual traffic volume counts. Number 2, discuss different ways of presentation of traffic volume data. Number 3, what are the different uses of spot speed data? Number 4, what are the errors normally occur during spot speed studies by field measurement of travel time over a short distance? Try to answer to these questions. The answers I will discuss during the next lesson. Quickly trying to answer to the questions of lesson 2.2. Uninterrupted flow facilities is basically where there is no external factor, that we call uninterrupted flow facilities. The stream parameters are macroscopic parameters and microscopic parameters, both are used. Speed, traffic volume and density are the macroscopic parameter, and headway is the microscopic parameter. What are the difference between the time mean speed and space mean speed? State the relationship. You know, the time mean speed is the average speed at one point or location observed over a period of time. It is the arithmetic mean of the speed observed at a point, and space mean speed is the average speed of vehicles over a certain route length at any time. It is harmonic mean of the speed observed at a point, and normally always space mean speed is less than equal to time mean speed. There is a relation, if you know either space mean speed or the time mean speed and the standard deviation or the variance, you can calculate the other thing using the well defined relationship. PCU, you know that mixed vehicle, we try to express them to single vehicle type using the concept of PCU. So, it is the number of passenger cars having the same impedance effect as a vehicle of a given type under prevailing roadway traffic and control condition. There are factors which are affecting PCU: vehicle characteristics, transverse longitudinal graphs, traffic composition, speed distribution, volume to capacity ratio, roadway characteristics, geometrics like gradient curves, access control, etc., traffic control and regulation, environmental and climatic condition. Show the Green-Selps linear speed model relationship and prove this relation Q max equal to Vf by Kj. So, this is the linear relationship given by Green-Selps. If you use Vs equal to Q by K, that is flow equal to speed into density, then you can get equation 2 and equation 3. You can express Q in terms of K and Q in terms of speed. So, take derivative dq dk equal to 0, that will give you the K value at capacity. Make dq dv equal to 0, that will give you V value at capacity. So, at maximum flow or capacity, Vm into Km, which is nothing but Vf into Kj by 4. Thank you.